Hello everyone, welcome to our Tripoli G1A project. Our project was two-way drone delivery system. We are group 5. The members of our group are IDs 40, 42, 43, 51 and 54. In our usual courier delivery system, we face various problems. Often a package does not reach the customer at an expected time and also sometimes ends up in a wrong address. The goal of our project was to address this issue with a drone delivery system. We have built a quadcopter that can locate a destination through GPS and deliver a package accurately and within a stipulated time. Here we can see the components we have used to build the quadcopter. For the motor controller, we have used 4 brushless DC motors and electronic speed controllers. BLDC motor uses an electronic closed-loop controller to switch DC current to the motor windings, producing magnetic fields, which effectively rotate in space and which the permanent magnet rotor follows. The 4 ESCs are used for controlling the speed of the BLDC motors. A signal from the flight controller causes ESC to raise or lower the voltage to the motor, thus changing the speed of the propeller. For the flight controller, we have used an Arduino Nano. The ESCs, gyroscope, and receiver are connected to the Arduino Nano. An IMU 6050 module has been used for the feedback device, which contains a gyroscope and an accelerometer. The gyroscope measures rate of rotation, and the accelerometer measures linear movement in any axis. These results are fed to the Arduino Nano. A GPS module and antenna are used as the location module. For controlling the direction, a magnetometer is used. For balancing the system, we have used PID controller. The gyroscope sensor detects angular velocity in 3 axes. So it can detect the rate of change of angle in pitch, roll, and yaw. The change in angle information is used to provide stability to drone and to prevent it from wobbling. The information from gyroscope is fed to the flight controller, which calculates each motor speed using PID algorithm dynamically to provide the stability of motor. In our project, it also ensures that the drone rotates at exact angle, which is necessary in accordance with GPS information.
Now there comes the product delivery part. When drone reaches destination, it decreases altitude and at a servo motor rotates its handle 90 degree and the product gets released. We use location tracking server GPS satellite client system in our tracking mechanism. After delivery, drone gets uplifted and returns to the base in accordance with GPS module. For more sophisticated system, we'll try to add OTP feature in future. If OTP doesn't match, drone will return without delivering the product.
Here is the flowchart of the working module of our two-way delivery system. The base or the warehouse receives signal for the dispatch of the package. The base then transfers the signal to the allotted drone. It flies out, rising to a higher altitude to avoid obstacles and disturbances. The path is set to the delivery location with the help of magnetometer module and gyroscope. And the drone starts towards its destination. After it flies to the higher altitude, the drone is provided with the immediate location of the customer, and it tracks the location as it moves towards its destination. According to the architecture diagram, the GPS position of the distribution point will be read by the drone. After reading the exact position, it will monitor the current location of the customer and take the parcel away from the base. After reaching the delivery point, the drone will decrease its height and release the parcel using servo motor. After that, it will again increase the height and fly back to the warehouse. Our final project looks like this. Here we can see the complete setup of our drone. The frame is designed in such a way that the weight is as less as possible, so that we can fly the drone with limited power supply. We have set up all the modules that are required for the project and flight controllers on the frame. We can see the GPS module, the gyroscope, and the Arduino Nano on the top of the frame. And the delivery mechanism is also implemented under the frame, which can be seen in this picture. Finally, we have tested our drone in the field of Sherebangla Hall. Here in the left picture, the navigation point indicates the base, and in the right picture, the navigation point indicates the delivery point. We have flied our drone to deliver the package from the left side navigation point to the right side navigation point. And after delivering the package, the drone flied back to the base again. In the next part, the hardware implementation will be explained by our friend Monirul Islam and Habibullah Khan.
Now we will demonstrate our project and show its delivery capabilities. Take off without parcel. We can see that our drone can lift up from the ground and can hover in the air, even though there were turbulence that is created while it was on the ground during liftoff, balancing and free flight. Our drone can balance itself perfectly. We can see that it is floating in the air and following the command that is given to it. It can go further up in the air, but for safety purpose, we will not be flying our drone too high. Even when we'll be using it to deliver parcel, we'll be using around this height. Because the drone may go out of the range of our controllability, as the range of our radio module that we are using is not too big, and we may need to manually control the drone in case of some uncertain events. Here we are showing the controllability of our drone. We can see that the quadcopter is perfectly balanced. Here we have implemented the PID algorithm to take continuous feedback of our current gyro angle and then calculate the required speed of each of the propeller that is required for the quadcopter to be balanced. When we are sending external command to the quadcopter, we can see that it is still balanced while moving to the direction that is commanded to. Here the quadcopter is commanded to move backward, and it is moving backward. Then when it is commanded to land, we can see that the propeller speed is reduced and the quadcopter is landing. Here the quadcopter is commanded to move rightward. We can see that the quadcopter started to move right. Then when it is commanded to move leftward, it is moving left. Now the quadcopter is not given any command. It should be staying still, but there are some certain drift in the motion. As there were some vibration that is always present in the quadcopter, the gyroscope of our quadcopter was taking some noisy result. As a result, the quadcopter starts to drift, which we will try to calibrate manually. Here we try to implement the quadcopter altitude hold function. We are trying to keep the quadcopter hovering at a fixed height and then try to land it. The GPS module that we are using for location tracking needs to be connected to satellites to show the drone's position that will be used to deliver parcel. Here the LED blink means the successful activation of GPS module. Delivery mechanism. Here we have a delivery mechanism that we have implemented using a servo motor and a cardboard structure. We can see that the box attached to the servo motor will drop off when the drone is reached its destination. Here is another demonstration of the delivery mechanism. The servo motor arm normally facing upwards keeps the box from falling, and when the commanded, the arm goes down and the parcel is released. Take off with parcel. As the parcel was bigger than our drone leg, we had to fly it from our hand. But you can see that it can still balance itself with the load attached and can hover in the air. It can still move freely according to the command that is given to it.
Now we will demonstrate our drone delivery system. As we have seen in our previous delivery mechanism, a box is attached to a cardboard and a delivery location is provided to the drone. According to the coordinate location, drone will complete its flight. Now we are seeing that our drone is completing its flight to go to the destination. Now the drone come down to the ground, release the parcel, and then by increasing altitude it come back to the original position and land successfully. Here is our second clip of drone delivery system. We can see that existence of airflow against drone's flight path creates distraction to go to the original coordinate location. To prevent this, drone completed his flight just above the ground. Now the drone is releasing the parcel successfully, turning around and return to the original position in a little bit different way because the GPS module isn't working 100% accurately in this situation. Here is our third clip of drone delivery system. We can see that every time we have delivered product to different location. Though drone should complete his flight in a straightforward path, but due to some complications, as we have mentioned in second clip, that error of the GPS module and existence of airflow, the drone complete his flight in an uneven path. Actually, there is no unmixed good on earth, and yet our project is not an exception from that. Now this is our first video clip of failed attempts. In this video clip, after reaching destination, servo motor didn't work properly. As servo motor didn't work properly, the parcel wasn't released successfully and the drone lost control over it and fell down. Now this is our second video clip of failed attempts. Actually, first we can see the balancing problem of the drone and then the problem of attaching box to the cardboard. Because the air thrust of the drone rotates the box and it fell down. Actually, honestly speaking, we have faced a lot of failed attempts. From that, we have just shared only 2 of them.
So this was all about our project we could do in this short span of time. Although it was not perfect, it was a starting for us. We look forward to improving our project to next level. For that, we will have to install a better quality GPS module so that the drone goes straight following the command and deliver the product faster. We will have to install a higher range power supply. And last but not the least, we will include OTP confirmation method so that the delivery gets cancelled automatically if the customer is not there. Thank you so much for your kind attention. If you have any query or question, please let us know.